So today I will be presenting to you about electric vehicle or EVs. So what is electric vehicle? Electric vehicle is a type of vehicle that is powered fully or partially by electricity instead of conventional fossil fuels such as petrol or diesel. EVs use electric motor for propulsion and obtain energy from rechargeable batteries. These batteries can be charged using external power sources such as home chargers or public charging stations. Looking at the historical roots, electric vehicles were actually developed as early as the late 19th century, even before petrol-powered cars became dominant. EVs were popular in the early 19th because they were quiet, clean, and easy to operate. However, their use declined due to limited battery range, long charging times, and the rise of affordable petrol vehicles with better infrastructure. So, moving on to the modern development, today's electric vehicles use advanced lithium-ion battery technology, which provide longer driving range and better performance. Many governments also support EV adoption through tax incentive, subsidies, and emission regulation. As a result, EVs are now considered an important solution for sustainable and future transportation. Next, we move to the next slide. Electric vehicles can be classified into several main categories based on how they are powered and how they are charged. First, we have battery electric vehicle or known as BEVs. These vehicles operate entirely electricity and use rechargeable batteries to power an electric motor. They produce zero tailpipe emission and must be charged using an external power source. Next, we have hybrid electric vehicle or known as HEVs. This vehicle combine an electric motor with an internal combustion engine. The battery is charged through regenerative braking and the engine itself. HEVs improve fuel efficiency but still rely on petrol. Last but not least, we have plug-in hybrid electric vehicles or known as PHEVs. These vehicles combine features of both BEVs and HEVs. They can be plugged in to charge and operate on electricity for short distance, but they switch to petrol for longer trips. This makes PHEVs more flexible for users who travel long distance. We move to the next one. Electric vehicles are significant for several important reasons. First and foremost, in terms of environmental protection, EVs produce zero or very low tailpipe emission. This helps reduce air pollution and greenhouse gas emission, contributing to a cleaner environment. Secondly, EVs are known for their energy efficiency. They are more efficient than internal combustion engines because a higher percentage of electrical energy is converted into vehicle movement. Another key benefit is reduced dependence on fossil fuels. EVs help decrease reliance on non-renewable sources such as petrol and diesel, improving energy security. And lastly, EVs drive technological advancement and sustainability. They encourage innovation in battery technology, smart grid and sustainability transportation system, and supporting long-term economic and environmental sustainability. That's all from me. I will pass the next slide to Zulaika.
Thank you, Nadia. Moving on to the concept, I will explain the basic operating principles of electric vehicles. Firstly, electric vehicles operate based on electromagnetism. When an electric current flows through a conductor, it generates a magnetic field. On the other hand, a changing magnetic field can induce an electric current. This principle is important in electric motors and also regenerative braking systems, where electrical energy can be recovered during braking. Another concept is the Lorentz force. According to this principle, a moving electric charge in a magnetic field experiences a force that acts perpendicular to both the direction of motion and the magnetic field. This force produces torque, which is the fundamental reason why the rotor in an electric motor is able to rotate and drive the vehicle forward. Next, I will briefly explain the main types of electric motors in electric vehicles. There are two main categories, DC motors and AC motors. One type of DC motor is the permanent magnet DC motor, also known as PMDC motor. It has a simple design where permanent magnets are used to generate the magnetic field. These motors provide good starting torque and are economical, making them suitable for smaller applications. Another type is the externally excited DC motor, which uses a separate field winding to generate the magnetic field. This allows better control of speed and torque. However, this design is more complex and less efficient, so it is rarely used in modern electric vehicles. In modern electric vehicles, AC motors are more commonly used. One example is the asynchronous motor or induction motor. It is robust, economical, and requires little maintenance because it does not use brushes or commutators. In this motor, electromagnetic induction generates the magnetic field in the rotor, but it requires a complex control system such as a frequency converter. Another type is the synchronous motor, where the rotor rotates synchronously with the rotating magnetic field of the stator. This motor offers higher efficiency and better power density, which makes it highly suitable for modern electric vehicles applications.
Thank you, Zulaika. For this slide, I will explain some real-world examples of electric vehicle usage. Firstly, electric cars are one of the most common implementation we see today. Models like Tesla Model 3, Tesla Model Y, and Nissan Leaf are mainly used for daily commuting, especially in cities. These cars are suitable for urban and suburban areas because they do not produce tailpipe emission and their driving range is already sufficient for everyday travel such as going to work or university. Besides car, electric motorcycle and scooter are also widely used. They are very popular for short distance travel and last mile delivery, especially in crowded urban areas. This is because they consume less energy, are easy to charge, and can move efficiently in traffic congestions. Overall, these examples show how electric vehicles are already being applied in our transportation and urban mobility. Next, I will discuss the potential benefits of electric vehicle. The first benefit is zero tailpipe emission. Zero tailpipe emission means that electric vehicles do not release harmful gases during operations. This helps reduce the overall carbon footprint and contribute to cleaner air with lower environmental populations. In addition, charging electric vehicles using renewable energy sources such as solar or wind power can further minimize their environmental impact. Using green electricity also support sustainable and eco-friendly transportation, making electric vehicle a better option for long-term environmental protection. The second benefit is energy efficiency. Energy efficiency in electric vehicle refer to how effectively energy is converted into motion. Compared to petrol and diesel vehicle, a large portion of energy is used to move the vehicle forward. Less energy is wasted as heat and mechanical friction, which make electric vehicle more efficient overall. Because of this high efficiency, less energy is required to travel the same distance. As a result, fuel and operating costs are reduced while the environmental impact is lower, supporting long-term sustainability. Another important benefit is convenience of charging at home. Charging electric vehicle at home offer greater convenience compared to conventional refueling. There is no need to wait at busy fuel stations during peak hour, which helps save time. Frequent trips to petrol stations are also unnecessary, making daily travel more convenient. Electric vehicle can be easily charged at home and scheduled around daily routines such as overnight charging. When charging at home is not possible, fast charge and battery swapping service are available as reliable backup options. Next, lower running costs are an important benefit of electric vehicle. Electricity is generally cheaper and more energy efficient than petrol or diesel fuel. High energy efficiency are also means less energy is wasted during driving, which help reduce overall operating expense. In addition, using renewable energy such as solar panels can further lower electricity costs. Electric vehicles require less frequent service because they have fewer moving parts compared to petrol or diesel car. Lastly, modern EV batteries are designed to last for many years, which help reduce battery replacement costs over time. Overall, this benefit highlight the potential of electric vehicle as a sustainable transportation solutions. That's all from me. Now I will pass to Arisa, who will continue the next part.
What are challenges of electric vehicles? One of the challenges is high battery costs, high voltage system, charging infrastructure, and environmental impact. High battery cost is a major challenge of electric vehicles. Lithium-ion batteries require advanced materials and complex manufacturing processes to achieve high energy storage and power output. Batteries must have high energy density and low internal resistance in order to operate efficiently. Achieving these properties is tough and costly, thus increases the overall cost of electric vehicles and makes them less affordable in today's economy. Next, electric vehicles operate using high voltage electrical systems, typically between 300 volt to 800 volt. Although high voltage reduces current in a given power and minimizes resistive energy losses, it possesses serious safety concern. If the battery of its wiring is damaged in an accident, there is a risk of electric shock or short circuits, resulting in explosion and fires. One fault in one part of the system can affect the whole vehicle. Because of this, electric vehicles require strict handling procedures to minimize the risk. Moreover, limited charging infrastructure is a major challenge for electric vehicles because electric vehicles require a stable electrical grid that is capable of supplying high power. According to Joule's first law, the power of heating generated by an electrical conductor equals the product of its resistance and the square of the current. This means that higher current and resistance result in greater heat generation in charging cables, connectors, and batteries. This will increase the risk of overheating and public safety concerns. Lastly, it raises impact in the environment as well. I say this because during the production stage in battery manufacturing, lithium-ion batteries require materials such as lithium, cobalt, and nickel. These materials are obtained through energy-intensive mining and processing activities. According to the law of conservation of energy, the large amount of energy used in these processes is mostly converted into heat and waste, contributing to environmental pollution and greenhouse gas emission.
Now I will explain the future developments and innovation in electric vehicles. Firstly, advanced battery technology such as solid-state batteries help improve safety and allow electric vehicles to travel longer distance on a single charge. Second, faster charging systems like ultra-fast and wireless charging make charging quicker and more convenient for users. Third, vehicle-to-grid or we call V2G technology where electric vehicle can send electricity back to the power grid, helping to save energy. Electric vehicles also include advanced driver assistance and self-driving features which improve safety and reduce accidents. Fourth, as the technology improves, the cost of electric vehicles will decrease, making them more affordable and accessible to the public. Next, let's look at other future innovation in electric vehicles. Regenerative braking helps save energy by reconverting braking energy into electricity, which reduces energy waste and lower costs. Lastly, the use of sustainable materials like recycled and eco-friendly materials can support green manufacturing and protect the environment.
Thank you, Mariam. Next, for the conclusion, electric vehicles are a cleaner and more efficient alternative to petrol cars. They help reduce pollution and support environmental sustainability. Although challenges still exist, such as higher costs and limited charging stations, technology is improving fast. Because of this, electric vehicles have strong potential to become a major eco-friendly transport choice in the future. Last but not least, here are our references. All information in this presentation was taken from legitimate website and according to APA style. Thank you for watching.